Hello everyone and welcome to the lecture on Amazon EKS Anywhere. So this lecture will contain all these topics. What is Amazon EKS Anywhere? EKS Anywhere, Enterprise Support and AWS Service Integration. What is the EKS Connector? Administrative and CLI components, management components, cluster components, standalone clusters, management clusters, control plane, compute, management, functions and tooling. So what is Amazon EKS Anywhere? Amazon EKS Anywhere is a container management software that simplifies running Kubernetes clusters on premises and at the edge. And EKS stands for Elastic Kubernetes Services. It is built on Amazon EKS distro, the same Kubernetes distribution used by Amazon EKS in AWS Cloud. EKS Anywhere simplifies on-premises Kubernetes management through automation of infrastructure setup and cluster lifecycle operations. EKS Anywhere supports VMware vSphere, Bare Metal, AWS Snowball Edge, Apache CloudStack, and Nutanix, and can run on Docker for dev test deployments. It is built on Cluster API, Kubernetes subproject, which provides declarative APIs and tooling for managing Kubernetes clusters. EKS Anywhere, Enterprise Support and AWS Service Integration. Amazon EKS Anywhere is open source and free to use at no cost, thus requiring no licensing fees. Users can purchase enterprise subscriptions to access 24/7 AWS expert support and gain access to AWS built, tested and supported EKS Anywhere curated packages. EKS Anywhere curated packages extend core cluster functionalities through AWS maintained software packages. Integrations include the EKS connector for console visibility, AWS IAM for cluster authentication, IRSA for pod to AWS service authentication, and OpenTelemetry for Prometheus-based resource monitoring. So what is the EKS connector? The EKS connector is a Kubernetes software agent that runs on clusters and enables registration with Amazon EKS console. So since you are running outside the AWS, so EKS connector will allow you to see the EKS Anywhere cluster, but you can see it, access it via the AWS management console. It provides console integration by connecting any conformant Kubernetes cluster to the Amazon EKS console, supporting clusters across multiple environments. The connector enables cross-platform connectivity for EKS Anywhere on-premises clusters, self-managed EC2 clusters, and non-AWS Kubernetes cluster. Users gain unified cluster management through the console, which allows visibility of all connected clusters, monitoring of Kubernetes resources, and location-independent operational oversight. So I'll talk about some administrative and CLI components. First, we have EKS CTL, CLI, which is the command line tool to create, upgrade, delete, management, standalone and optionally workload clusters. So there are three types of clusters which I'll talk about. Image Builder. So this is a command line tool to build Ubuntu and Red Hat Enterprise Linux node images. Then finally, we have Diagnostics Collector, which is the command line tool to produce support diagnostics bundle. Now I'll talk about the management components. So first is Cluster API Controller. So this controller manages the core cluster API objects such as cluster, machine, and machine health check. Then we have EKS Anywhere Lifecycle Controller. This controller manages the EKS Anywhere objects such as EKS Anywhere clusters, EKS A releases, Flux config, GitOps config, AWS IAM config, and OIDC config. Curated Packages Controller, and this controller manages the EKS Anywhere curated packages and objects. KubeADM Controller, and this one manages the Kubernetes control plane objects. Then we have ETC ADM Controller, and this manages all the ETC objects. And we have some provider specific controllers, and these controllers interacts with the infrastructure provider like vSphere, Bare Metal, etc. that manages the infrastructure objects. Then we have EKS Anywhere custom resource definitions, CRDs, and these custom resource definition that EKS Anywhere uses to define and control infrastructure, machines, clusters, and any other objects. Now some cluster components. First we have Kubernetes. The Kubernetes components that include the Kube API server, Kube controller manager, Kube scheduler, kubelet, and kubectl. Then we have etcd, which is the etcd database used for Kubernetes control plane data store. Then we have Cilium, which is the container networking interface CNI, and Core DNS, which is in-cluster DNS. Kube proxy, which is the network proxy that runs on each node. Containerd, which is the container runtime, and Kube VIP. This is the load balancer that runs on control plane to balance control plane IPs. So the first one, there are two clusters type, standalone and management. So standalone clusters share technical similarities with management clusters but differ by exclusively managing their own operations without overseeing other clusters. Cluster creation begins from an admin machine regardless of deployment architecture, establishing the foundational setup for standalone operations. A temporary kind bootstrap cluster facilitates the creation process by retrieving necessary components and initializing the standalone cluster on the selected infrastructure platform. And this solution offers infrastructure flexibility, enabling deployment of standalone clusters on any user-chosen infrastructure environment during the bootstrapping phase. Next is management clusters. Management clusters are long-lived EKS Anywhere clusters designed to create and manage multiple workload clusters, maintaining operational continuity for cluster management. These clusters operate both management and core cluster components, while workload clusters focus exclusively on running applications without the management overhead. Workload clusters serve as a dedicated environments for application execution, separating operational concerns from management infrastructure. Centralized cluster management is achieved through Kubernetes compatible tools including kubectl, GitOps workflows, and Terraform integration, providing unified control mechanisms. The architecture ensures resource isolation between management components and application workloads, preventing operational interference in workload cluster environments. Next, I will talk about control plane. So far, we have Kubernetes control plane management, and this is a comparison between EKS Anywhere and Amazon EKS service. So in case of EKS Anywhere, it's managed by the customer. EKS is managed by AWS. Kubernetes control plane location, EKS Anywhere, so customer managed infrastructure, and second is AWS cloud. And any cluster updates, so it is customer managed updates for control plane and worker nodes, so both. In the AWS EKS, Amazon EKS, AWS managed in-place updates, so it's managed by AWS for control plane, and AWS managed updates for the worker nodes, so both is managed by the AWS. Next, compute, so the comparison. So EKS Anywhere can run anywhere, as I talked about, vSphere, Bare Metal, Snowball Edge, CloudStack, Nutanix. But EKS Cloud, we have two options. You can either choose EC2 when you create the cluster, or the Fargate, which is serverless compute. Then node operating systems. So for EKS Anywhere, you can use BottleRocket, Ubuntu, and RHEL. For EKS Cloud, you can use Amazon Linux 2, Windows Server, BottleRocket, and Ubuntu. Physical hardware is managed, customer managed, and EKS is AWS managed for the control plane. For the compute, whole compute. And whether it's serverless or not, so serverless is not supported for Anywhere. But for EKS Cloud, we have the AWS Fargate option, and it can run, as I talked about, EC2 and Fargate. So Fargate is serverless. And talking about management, so command line interface CLI we use for EKS Anywhere, EKS CTL CLI. But for EKS Cloud, we have two options. EKS CTL plus AWS CLI can also be used. AWS console view, so it is optional with EKS connector. So it's optional If you want, you can install EKS connector and then you can see in EKS console. But for EKS cloud, it's anywhere native console integration. So next is infrastructure as code. So Kubernetes API compatible tooling. So this provides, EKS Anywhere provides any Kubernetes API compatible tooling, Terraform and GitOps. For EKS Cloud, we have CloudFormation also, Terraform and GitOps. And logging and monitoring. So in both the cases, we can use CloudWatch and Prometheus. And last point is about GitOps. So for EKS Anywhere, you can use a Flux controller. And for cloud also, EKS Cloud also Flux. So in both cases, you can use a Flux controller. So basically, you submit all your YAML Kubernetes object, and this Flux project, this technology will directly push as soon as it gets committed to the Git repository. And next, comparison in the field of functions and tooling. So first feature, networking and security. So EKS Anywhere, you can use Cilium CNI and network policy supported. So both for the EKS Cloud, we have Amazon VPC CNI supported with other compatible plugins. And load balancer for the EKS Anywhere, we have Metal Load Balancer. So this is a specific project or the technology. And EKS Cloud, we have the Elastic Load Balancing. Then for service mesh, we have community solutions for EKS Anywhere. For AWS Cloud, we have a couple of options. We have one service or component called AWS App Mesh, and all the community provided solutions also. And lastly, community tools and Helm support. So it's compatible. EKS Anywhere is compatible with community tooling, and same for EKS Cloud. Both are same in this area. And that's all. Thanks for watching.